Hello, my name is Rocío Tarjuelo. I am a postdoctoral researcher at the Universidad de Valladolid, and I'm going to talk about the use of artificial intelligence in wildlife management, more particularly on animal management. So as an ecologist, I think I should start from the most basic. So what is artificial intelligence? Artificial intelligence is a broad field of computer science that enables machines to take their own decisions without any human intervention. And within artificial intelligence, machine learning has been widely used in the field of ecology. Machine learning simply refers to the algorithms that learn from data without human intervention, without human guidance. Machine learning has been used in ecology for estimating spatial distribution or ecological niches of species, considering different scenarios of global change, to understand biotic interaction, or to model variation in abiotic components of the ecosystems, using different machine learning tools such as generalized additive model, random forest, or support vector machine, among others. And this study using machine learning has a strong applicability in conservation and management of wildlife. But nowadays, the use of artificial intelligence has turned the focus into how to process the large amount of ecological data available collected from camera traps, acoustic sensor, biologgers, or even data from social media. And this can greatly improve the management of wildlife populations by saving money and time from population censuses, or even detecting illegal trade and poaching. But in this talk, I'm put the focus on a topic that I'm now working on, which is the increasing number of collisions between cars and animals that are observed in many regions of the world. In this very recent study, Rilo and co-authors estimated that 184 million birds and 29 million mammals can be killed each year in European roads. And indeed, road mortality is an important source of direct mortality for that compromise the persistence of many populations and can even cause extinction, could even cause the extinction of several species, as those highlighted by these authors. But when collisions occur with heavy animals, they also compromise the security of human beings. Populations of large ungulates such as deer and wild boars are increasing in many regions of Europe and North America. And here in Castilla y León, we have observed that car collisions with the roe deer, the red deer, and the wild boar have increased by 270% between 2006 and 2018. These species are the most abundant ungulates and can cause several important economic losses, as well as injuries and even death in case of collision with them. And unfortunately, this upward tendency is expected to continue as the favorable conditions that allow the expansion of these species will not revert in the short or mid-term. Currently, road fencing, road signals, and over and underpasses are the commonest measures to prevent collisions with these animals. But artificial intelligence can help mitigate this high number of collisions and increase road safety, which is a major goal for the United Nations for this decade. Artificial intelligence can be used, as in other studies, to improve our knowledge on the environmental and biotic factors that increase the probability of having a collision with these species. And artificial intelligence can also be integrated into animal detection systems that are currently used to decrease the high number of collisions. There are different types of animal detection systems, and what they do is that when they detect an animal crossing the road, this triggers the activation of road signals such as warning lights to alert drivers of the presence of animals in the road, so drivers can reduce the speed. These systems use different types of signals such as images, sounds, and infrared radiation to detect animals, and they have indeed provided positive results in reducing the car collisions with heavy animals. But such animal detection systems present several weaknesses, and one of them is the high rate of detection errors, including false positives and false negatives, caused both by bad weather conditions and dense vegetation close to the road. And this high rate of false detection can reduce drivers' credibility of warning signals. So integrating machine learning into animal detection systems can reduce the high false rate detection errors by improving the detection of animals when they are in the road, and this will increase the reliability of these systems to increase road safety. I'm just going to mention two of the very few studies that are applied to detect animals on roads and that uses machine learning. In the first study, the authors aim to develop a system that can recognize animals crossing the road. So they train different machine learning tools to discriminate between animal and non-animal areas in road images. In these images, the green pixels reflect correctly areas identified as an animal. In the second study, Sousa and colleagues developed a mobile mapping system that is in the upside of the images that can detect amphibians and small birds, both dead or alive, using convolutionary neural networks. But even this study that uses machine learning still presents a relatively high rate of false detection, and a crucial step yet lacking in this research field is the creation of data sets specifically collected for the purpose of training machine learning to detect animals on the roads. And in this sense, advances from the field of conservation biology to monitor wildlife by identifying animals or even behaviors, and also intruders into protected areas, can greatly benefit the applicability of artificial intelligence in increasing road safety. Another interesting point is that citizen science and artificial intelligence can together contribute to mitigate car collisions with animals by providing data and identification of species using smartphones. So citizen science can use a smartphone application with artificial intelligence to identify animals that have been killed on road, and send this information to centralized databases that then apply more complex artificial intelligence tools that can perform tasks on identification and classification of animal species. And in this line, a new research project launched by the Spanish Ministry of Ecological Transition last year, in collaboration with research group and several entities related to wildlife conservation, aim at improving our knowledge of wildlife mortality for all vertebrate types with the collaboration of citizens. However, one of the major limitations of using artificial intelligence for road safety is the high economic cost of installing animal detection systems. Europe has more than 70,000 kilometers of roads, and installing such systems in the entire network is simply not feasible. So I saw in this is the holidays, I saw these road signals that I'm sure you can see well. But I'm pretty sure they use artificial intelligence to alert drivers when an Iberian lynx is crossing this highway. But this can be done because there are very few Iberian lynx in this area, and their movements are controlled by GPS collars. So administrations are confident on where to install animal detection systems to prevent lynx fatalities. But a similar approach could be followed to reduce collisions with large ungulates using data from traffic authorities or even from citizen science projects. Can help to identify the most dangerous collision hotspots, and an animal detection system can be installed in these localities. However, collision hotspots can change over time, as these images show for the road deer, for collisions with the road deer in Castilla y León. So a continuous monitoring would be necessary to know where this animal detection system should be installed or even have to be moved to a new location. So to conclude, car collision with animals constitute a serious threat to biodiversity conservation and human safety. Artificial intelligence has a strong applicability to increase road security by alerting drivers when heavy animals are crossing roads, but yet the high economic cost and high rate of fault detection precludes its widespread use for mitigating collisions with heavy animals. However, research is in a very early stage and offers promising opportunities for collaboration between administration, enterprises, researchers and citizens to increase road safety for both human beings and wildlife. So thank you for your attention.